Bueno, estamos aquí llegando a la charla donde tenemos unos minuticos que se está listando.
Hello, everyone. We are here with Diogo Branco. Okay, so thank you, everyone, for joining us today. If you are on Facebook and YouTube, you can leave your questions on the comments, and we will transfer those questions to Diogo. We are here with Guy. He's a PhD student in informatic engineering, the branch of human-computer interaction at University of Madeira, and his background is in clinical psychology and self-taught programmer. He is very interested in the combination of technology to improve rehabilitation methods. Diogo, thank you very much for joining us, and the stage is all yours.
Hi, everyone, and thank you for having me here. So I'll be presenting the project I'm currently working on, called Lift Revision Applied to Neurorehabilitation Therapy, or in short and more easily to say, BRANT. Okay, so this is, oh, it's not changing. Okay, it's changing now. So, quick introduction. I'm doing my PhD in informatics engineering in the human-computer interaction branch. My background is in clinical psychology. I've worked as a research fellow in a neuroscience lab, and I've always been interested in the synergy between brain and machine, hence I went for a PhD in human-computer interaction. And I'm currently working on as a researcher fellow and programmer on the BRANT project. And my main contribution is the game development. So this is the lab I'm in now. Most of the research developed in the NeuroRehabLab, that is the name of the lab, is focused on the human-computer interaction and the use of technology to improve physical and mental rehabilitation. So here you can see some pictures of the lab, of the facilities, and some of the projects. I will left a link in the presentation, so if you have interest, you can check them in detail later. I'll briefly present some outputs. So here you can see on the first image it's an image from a project called Neuro. It's a brain-computer interface project that uses motor imagery paradigms and virtual reality. It's mainly used in motor rehabilitations and in particular stroke patients. Okay, the second image is from the Rehab City, a virtual reality game in which the participant can do multiple daily life activities like groceries, withdraw money, and read journals. It's used for cognitive rehabilitation and will be linked to the BRANT project that I will go more in depth. So the first image that you see here, it's from a cave that was built in our lab. It's extremely cheap when compared to the other expensive cave systems, yet it can perform at a safe level. If you are using Unity, you can get it for free at the Unity Asset Store. And in fact, all of these apps are available for free at the NeuroRehabLab website. But if you are using Unity, you can go directly to the Asset Store. Okay. Then you see an image of the MuSequence. That is a software that allows to create even motor tasks cognitive tasks for rehabilitations. It uses augmented reality and virtual reality. It's a very versatile software. You can see there a patient that is selecting an item. It's a projection that is being made on the table and detected as selecting an object. So here you can see the task generator. The task generator is a free tool for the generation of cognitive training tasks. Basically, you just need to insert some parameters, and then you can download a personalized PDF with exercise similar to the image. This will be very useful on the, this will be very to the BRANT project, and I will show you in the next slide, you will see why. So I will start to explain what the BRANT project is. The BRANT project goal is the development of a novel cognitive rehabilitation tool to allow the health professionals the monitoring and adaptation of treatment at home. In order to do this, we propose the usage of AI to improve the existing task generator tool that I showed you previously. Because the tool, although the tool is good to develop cognitive tasks and motor tasks, it's not designed to adapt and monitor the cognitive process of the patient. So it's a static. It's static and depends and relies on the health professional. BRANT will propose the usage of machine learning, deep learning, and belief revision frameworks, and to be able to assess the patient's deficits through the usage of result battery of validated neuropsychological assessments, generate gamified cognitive training tasks, Unity. Basically, they are games that are being developed in Unity, and that's my main contribution, that will be adjusted to each patient profile and support the continuum of healthcare. Okay. So, cognitive impairments due to brain lesion, dementia, or simply the normal cognitive decline is something that is very common, yet it has lots of impacts on the performance of activities of daily life and limits people's independence by monetary and social costs. And so far, the best tool that we have to deal with it is cognitive rehabilitation therapy, but like with everything, isn't perfect. So the first limitation is that the rehabilitation tools lack personalization. So a tool is not adapted to every patient. So there is a standardized tool and it's used, but may not work with it because every patient is different. Interventions can be expensive, time-consuming, and are usually implemented in clinical environments. So how can this issue be surpassed? We introduce the BRANT, that is an enhancement to the task generated, is extended in improving training content and AI models that allows through gamification to remote monitoring capabilities to enable the health profession to provide long-term personalized cognitive rehabilitation at home. So this is the BRANT framework, the overall project, and I'll guide you through each phase. Okay, change already. As you see that the health professional will use a neuropsychological assessment tools to basically to assess the patient and start to building a profile. Then the results of these tests will be injected in the database and mapped to values, which creates a normalized patient cognitive profile where each factor or cognitive domain is normalized from 0 to 100%. Then, once the cognitive profile is created, it is compared with the normative data of these tests to define the cognitive status. Basically, you want to know the position of the patient when compared to the standardized test data. And for that, it's necessary to incorporate new information such as social demographical information. Okay. The health profession can then interpret the cognitive status and specify training objectives. Like you can, I don't know if you can see, but in A, B, and C, you can see the percentage for that particular profile, where the set number of parameters of the training tasks are suggested. At the same time, the initial difficulty of the training is set based on the cognitive profile. At this time, the belief revision engine tries to predict the expected results of the training task. In 5, the patient performs a gamified training task at home and performance is communicated to the belief. Then the results of the participant are compared with the expected ones based on their cognitive profile. And three things can happen. Three outputs can happen. A, if the patient performance is in accordance to the expectation, then it will continue. If the data shows that the patient shows an evolution or an involution, the patient profile is updated and a new set of difficulty is set. This is a key aspect because we want the participant to feel engaged. So the task should not be too difficult, so the participant won't feel frustrated, and should not be too easy, so the participant won't feel engaged in doing. And C, statistically unlikely changes or inconsistent data is detected. If this is the case, then the health professional is contacted to reassess the situation and train the belief revision. So basically, we have to fine-tune again the framework. Finally, the health professional will do a new neuropsychological assessment reassessment, basically, after the intervention is complete, in order to quantify the impact of cognition with this framework and decide if more therapy is required. So, what is being done at the moment? At the moment, the artificial intelligence team is inserting the standardized neuropsychological tests data into the database, and will soon start to train the neural networks models and fine-tune it. We are developing the graphical user interface. We are planning on doing basically to test the graphical user interface from a patient standpoint and the health professional standpoint. So we basically have to ask some individuals to do some user tests, so we can assure that everyone, or at least we have some data that shows that the system runs flawlessly and is intuitive. Then this is the part of the project that I'm more involved with, is the development of serious games using Unity engines. The mechanics of the games being developed are based in activities used in cognitive rehabilitation. They are somehow similar to the Rehab City that I presented earlier. We are aiming at developing games with the maximum ecological validity possible. Additionally, in order to understand how the games could be better implemented and more useful in a real world, a member of our team interviewed multiple neuropsychologists that work with cognitive rehabilitation to understand the needs and difficulties on interventions. So basically, we are building on the project that we already had in our lab, and we got the feedback from those projects, and then another therapist interviewed some other psychologists to work with cognitive rehabilitation to understand their needs and the patient's needs, and now you will implement in these newer games. So we want to achieve the maximum performance these games can go to rehabilitation. And now our techs are making intervention in nursery homes using tools such as Rehab City and Musicmas, and also are collecting data that can be used to train our model. As may happen with you, we had setbacks due to COVID-19, so the project got a little late in schedule, but we hope on the next year to the project to be all finished and fully implemented. So in short, BRANT, the goal of the BRANT is to develop a novel cognitive rehabilitation tool that allows the health professional the monitoring and adaptation of treatment at home, and that uses virtual reality serious games as training tasks. So reducing costs by doing a remote intervention, and a personalized therapy by adapting the difficulty of the games and the tasks based on the patient assessments. And yeah, that's it. Thank you. And if you have any questions, feel free to ask. I'm glad to answer them.
We have a question on YouTube. And the question is, what recommendations can you give for researchers in the neurocognitive field looking for VR-free softwares to test older adults?
To test what? Sorry, I couldn't hear you.
Older adults.
Test other adults. Okay, so yeah, in our lab we use tablets, and we use also the kinetics from the Xbox. Like we use the Xbox One kinetics and the Xbox from the 360 kinetics. They are all connected to our software from the Musicon software, and the Rehab City. And I think you pretty much can use any technology that is. It doesn't need to be very expensive, I think. Like the Wiimote, we have a lot of applications in our website that make use of these tools that were meant for gaming, like gaming in the proper sense of playing games, but are now being redirected to neurorehabilitation or rehabilitation. And I think you can successfully use it with elderly people. And yeah, that's it. Most of them are clinical validated in clinical tests. So I think if you want to know more about it, you can even go and check our website, and you will see our tools and the technologies that we use. But mainly they are focused on using technologies from the games and the Unity engine. Okay, thank you. Thank you for the opportunity of attending this and presenting on this wonderful event. Yeah, and I think it's going great. The event is going great. Congratulations on the organizer. And yeah,
thank you very
thank
much.
you.
And if people if someone wants to connect with you, maybe on LinkedIn, on social media, can you give them?
Yeah, I can paste. Oh yeah, I cannot hear. Yeah, you can. I was going to copy and paste to the chat, but you can. I mean, you can. Are you seeing my screen or no? Yeah,
yes.
you are seeing.
Yes.
Can you see my email? My email is in. Yeah, it's in there. Yep. You can connect me. Can find me on my email, and obviously on LinkedIn. And if you search for my name, Diogo Branco, and the NeuroRehabLab, it will appear my page related to our lab. So you'll find me there, and then you can find my LinkedIn. I mean, yeah, that's it.
Okay. Well, Diogo, thank you very much.